Good morning, ladies and gentlemen. This is 2.1, Numeracy and Algebra. We're going to get started with our Cycle 2 notes. This is going to combine about the first 3 lessons from the last cycle. So we're going to move through this fairly quickly. Rational numbers. So rational numbers are numbers that can be written as fractions. Remember, we had irrational numbers like root 2. In this case, we're only dealing with rational numbers for today. Bedmas, so just as a quick review, that's brackets, exponents, division, multiplication, addition, subtraction. In that order, of course, division, multiplication is interchangeable, and addition and subtraction are also interchangeable. Finally, reduce your final answers. No mixed fractions, so you can leave them as improper fractions. So 4 over 3 is okay. Okay, let's get started. Here we have simplify, and in this actual question, there's a few things I want to point out. I'm going to pick a different pen color. All right, and really, because of bedmas, we have 1/2 plus 4 over 3 divided by 2 over 5, and because of bedmas, we actually have to do our division first. So you can really think of it as like a bracket here. We're going to do our division, so we'll have 1/2 plus whatever our division is. Well, that's really just 4 over 3 times 5 over 2. Because whenever you divide by a fraction, you flip the second fraction. So in this case, we flipped the 2 over 5, it became 5 over 2, and now we multiply the fractions. So now we're left with 1/2 plus, well, 4 times 5 is 20. And then 3 times 2 is 6. And before you can actually add fractions, as you know, you need to have a common denominator. So we're going to multiply the numerator and denominator of the first term by 3. So we'll have 3 over 6, which is just 1/2, plus 20 over 6. So we'll end up with 23 over 6. And you actually can't reduce this because 23 can't divide by 2 or 3. Which is our prime factors of 6. So that stays as it is. Next question, we have a lot going on. The way I think about fractions over fractions is whatever's in the numerator is its own set of brackets, and whatever's in the denominator is its own set of brackets. So before evaluating, we got to figure out the numerator and denominator before doing our final division. On top of that, we actually need to convert these mixed numbers into improper fractions. So that means that we'll also have to change to like terms because we're doing subtractions here. So first, let's convert into improper fractions. So 2 times 4 plus 1 is 9. So it'll be 9 over 4. 1 times 2 plus 1 is 3. So we'll end up with 3 over 2. And this should all be fairly straightforward and review. You guys should have seen this a couple times by now. 1 times 8 plus 7, you get 15. And that's 15 over 8. Subtract 3 over 2. Okay, now we can just solve for the top part. If we're solving for the top part, we have 9 over 4, subtract 3 over 2. Well, a common factor or a common denominator would be 4. So we'll leave the first term, multiply the top and the bottom of the second term by 2. So we should get 6 over 4. Then we can do our subtraction there in our next step. In the denominator, we have 15 over 8 and 3 over 2. The least common denominator would be 8. So we're going to leave the first term as 15 over 8. Then we have to multiply everything by 4, so we get 12 over 8. And now we can do our subtractions. So now we do our subtractions, we get 3 over 4, which is divided by 3 over 8. And because you're dividing fractions here, it's really just 3 over 4. Let me just rewrite this. Divide by 3 over 8. Well, you're just multiplying fractions, but you flip them. make sure that's a times, not a plus. So 3 times 8 gives us 24. 4 times 3 gives us 12. Well, 24 divided by 12 gives us 2, and we are done. Okay. And that's just basic bedmess using fractions. Let's go to the next slide. Proportions. Okay, so for proportions, you need to learn how to cross multiply. I did reveal the names of the categories on the table just so they're a little bit neater to read. So obviously I can't write that neat. When investigating what types of pets students had, it was determined that in a class of 30, the ratio of dogs to cats to birds was 5 to 7 to 1. So dogs was first, then cats, then birds. If there were a total of 65 pets counted, determine the number of cats and dogs. So there's a lot going on in this question. Let's just set it up. We know there was 5 dogs because that was the first number and the first thing said. Then cats, so that would be 7 here. And then 1 bird. Now for the total, this is where this question gets a little tricky. It says 65 pets total were counted. However, the ratio doesn't add up to 65. If you actually add 5 plus 7 plus 1, you get 13. So 13 goes over here. Your actual total goes underneath. So now you're left with 4 different fractions, one representing dogs, cats, birds, and then 1 for totals. So to figure out the number of dogs, you actually just set it up. Let's say our unknown value is D for dogs, 5 over D. And this is going to be equivalent to our ratio of 13 over 65. Now you actually use the method of cross multiplication. So 5 times 65 divided by 13. And then you should get D equals 25. So there's 25 dogs. Same idea. Let's set up for cats. Let's see here. Now, notice that we're not calculating birds. That's because we're determining the number of cats and dogs, not the number of birds. So we don't actually have to do anything with that. Number of cats would be 7 over C is equal to 13 over 65. 7 times 65 divided by 13. So that equals 35. So there's 35 cats, 25 dogs, and 65 pets total. Okay, let's move on to the next slide. Percent is a ratio of 100. That was covered up. Yeah, percent, because cent means 100. If you think of dollars and cents, that might help you remember what cent means. Centimeter means 100 or 1/100th of a meter. So cent is, I believe, Greek for hundredth. So for percent, it's per 100. First example, how much would it cost to purchase a $150 item that is 13% off, and then there is 13% tax added back to the sale price? Well, first you have to determine the sale price, then you determine the tax added on. There is a quicker way, and we're going to go through that. First, the actual sale price is times 0.87. And the reason why it's 0.87 is because 1 minus 0.13 equals 0.87. And if there's 13% added back to the price, you multiply by 1.13. So what we're going to do is we're going to take 150, multiply it by our sale price, or percentage, because we take 13% off, then whatever that is, multiply it by 1.13. Now, because it's multiplication, you didn't need to put the brackets in. I'm just showing you the first steps when I put it in my calculator. And then when you actually calculate it out, you should get 147.465. But now we have to round it, so the final cost is 147.46 or 47 if I'm rounding properly. Okay, so that's just percentage. Take a percentage off, we see that. Add a percentage on, we see that as well. This covers just about everything that we deal with percent in this grade. Next we have exponent laws. Exponent laws are pretty straightforward. Once you have these memorized and you understand them and how they work and why they work, being able to deal with the actual questions becomes much easier. This is your second time seeing it, but I will go over it again with you, and we will take the questions slowly. Okay, so exponent laws. We have a to the power of m times a to the power of n. This means we add our powers. So we have m plus n. Because they're the same base. See how they're both base of a? And then they have their own separate powers. That's when we add the powers. When you're dividing, that's when you subtract the powers. So m minus n. So it'll be a to the power of m minus n when it's a to the power of m divided by a to the power of n. Next one, we have a to the power of m all to the power of n. And what happens here is you will have a to the power of m times n. So it'll be a times n, or m times n. Or you could write it a m n. Both are acceptable. That looks like an x. Just keep in mind that's a multiplication sign, not an x. A to the power of 0 is 1. Anything to the power of 0 is always 1. A to the power of negative n is just 1 over a to the power of n. Or you could write it as 1 over a to the power of n. And finally, we have a fraction, a over b to the power of negative n. You just flip the fraction, so you end up with b over a, and that'll be to the power of n. Now, this would also mean that you apply the power of n to both the numerator and denominator. So you have b to the power of n over a to the power of n. Okay, that's all your exponent laws. Make sure you write this down. If you struggle with these, try just making sure you know these as you work through the practice questions. Maybe go back and do the practice questions for exponent laws. That might help you solidify your knowledge in this. Once you actually understand the rules and how they work out, the questions get much, much easier to understand because we throw a lot at you. And especially in the next example, you're going to see that. Okay, next slide. So I have 4 examples here, and it looks like there's a lot going on. Just take it one small step at a time. And in our first example, we actually have 2 over 3 to the power of negative 8 times 2 over 3 to the power of, well, if it's not written, it's really to the power of 1. And remember our first rule. We're going to deal with the numerator first, then the denominator. So let's just talk about the numerator right now. We have basically a to the power of negative 8 times a to the power of 1. So we're going to add the powers together. You have 2 over 3 to the power of negative 7. Because negative 8 plus 1 gives you negative 7. All right, now we're going to figure out our denominator. There's a lot going on. We have a power of a power, then we have a multiplication. First, we got to deal with our power of power in the first term. So we have 2 over 3 to the power of 4 to the power of negative 5. Whenever you have power of a power, you multiply them. So 4 times negative 5 gives you 20. So we're going to end up with 2 over 3 to the power of negative 20 times 2 over 3 to the power of 10. Now let's keep simplifying the denominator, so it's one term. We'll have one term in the numerator, one in the denominator, and we can work from there. So let's get to that. We have 2 over 3 to the power of 7 all over, well, negative 20 minus, or negative 20 plus 10, because it's a power times another power. So it's base 2 over 3 to the power of negative 20 times base 2 over 3 to the power of 10. So that means you add your powers. Negative 20 plus 10 gives us negative 10. So we are left with 2 over 3 to the power of negative 10. Now, here's where things get interesting. We have negative 7. My negative 7's not really showing there. There we go. That looks a little bit better. 2 over 3 to the power of negative 7 divided by 2 over 3 to the power of negative 10. What you do is you subtract your powers. So negative 7 minus negative 10 is going to give us positive 3. So we'll end up with 2 over 3 to the power of 3. Now, whenever you have a fraction like this, and it's to a power, you apply the power to both the numerator and the denominator. So we do 2 to the power of 3 over 3 to the power of 3, which is just going to give us 8 over 27. And then we're done. All right, next question. There's a lot going on. We're dividing. We have 2 separate terms. We're going to deal with the first term, then the second term in the first step, and then we'll deal with the division, and then we'll deal with everything else that comes after that. So first term, 3 over 4 to the power of 2 to the power of negative 4. It's power of a power, so you multiply. So you have 3 over 4. Well, 2 times negative 4 gives us negative 8. And then that's going to be divided by whatever this is. It's still going to be 3 over 4. The base isn't going to change yet. We're not going to do that until the very end. We have 3 over 4. It's the power of negative 3 to the power of 2. So that's negative 3 times 2. That's going to give us negative 6. All right. So if we are dividing 2 exponents with the same base, that means we subtract them. We have negative 8 minus 6, or negative 8 minus negative 6, which is going to turn it into a positive 6. So positive 6 being added to negative 8 will just give us negative 2. So negative 8 plus 6 gives us positive 2. Or negative 2. Because negative 8 is greater, so it's going to stay negative. All right. Now we have 3 over 4 to the power of negative 2. The way I would suggest doing this is flip the fraction and take that negative out first. So then you have, oops. So then you have 4 over 3 to the power of 2. Then you plug in the power of 2 to both the 4 and the 3. 4 squared is 16, and 3 squared is 9. And we are done with that question. Okay, moving on. Next one's a little bit trickier, just because we have 2x squared to the power of 4. The letter aspect of this is actually going to be a bit easier, but because there's a number and a letter, you have to apply the power outside of the bracket to both the number and the letter. So whenever power of 4 is going in, it's going to apply to this 2 here, and it's also going to apply to the base 2. So 2 to the power of 4 times x to the power of 2 times power of 4 there. So it's going to be 2 times 4, or x to the power of 2 times 4, and 2 to the power of 4. 2 to the power of 4 is 16, and x to the power of 8. And we are done with that question. Pretty straightforward. The toughest part is understanding that that 4 goes into both the letter and the number. Okay, next example. we're going to simplify and get everything as one power, and then we'll deal with it from there. So let's deal with the numerator to start and the first term. So we have x to the power of 5 to the power of negative 1. 5 times negative 1 becomes negative 5. And then this is going to be multiplied by our second term. X to the power of 6 to the power of 2. Well, that's just going to become x to the power of 12, because 6 times 2 gives us 12. And then in our denominator, our first term is x to the power of negative 4 to the power of 5, which is going to give us x to the power of negative 20, because negative 4 times 5 gives us negative 20. Then our final term in the denominator, x to the power of 3 to the power of 9, well, that's going to give us x to the power of 27, and that's because 3 times 9 gives us 27. Okay. Now we have two multiplications, and they're the same base, so we can just add the powers in the numerator and the denominator. So let's do the numerator first. We have x to the power of negative 5 and times x to the power of 12, so we add our powers together. Negative 5 plus 12 gives us 7, so we are left with x to the power of 7. Then in our denominator, we have x to the power of negative 20 times x to the power of 27, so negative 20 plus positive 27 gives us x to the power of 7 here. We are done with that. Now, when we subtract, because it's x to the power of 7 minus 7, because when we're dividing the same base, we subtract the powers. So 7 minus 7, we end up with x to the power of 0. And anything to the power of 0 is just equal to 1. So if you get the power of 0, it just equals 1. And that's the final answer for that. Okay. That should be enough for exponents for now. Let's move on to the next slide. Expressions. Okay, this is something that we have been dealing with in quadratic relations, and you guys have been wonderful in dealing with this. We've been doing a little bit of FOIL and working backwards. So what we actually need to do is expand, which means multiply the brackets, and simplify, collecting like terms. Then multiply by binomials. To do that, that's when we use FOIL. And FOIL stands for first, outside, inside, and last. Or if you speak, or if you remember it the way that I said it the first time, I think I said first, outer, inner, last. Whatever helps you memorize this. I am going to go over this. I know when I first taught this, I messed up the arcs to show you what you're multiplying by. So let's just make sure we get it right this time. Example 5, expand and simplify. So the first one, we're not using FOIL, we're just expanding the brackets. Let's expand the first bracket. 2 goes into both terms, so 2 times 2x gives us 4x. 2 times negative 3 gives us negative 6. And then when we expand this in, we have to be careful because it's negative 4 that we're expanding in. So negative 4 times x gives us negative 4x. I forgot my equal sign at the start. Negative 4 times negative 5 gives us positive 20. So we're left with positive 20 there. Now we collect like terms. And if you have multicolored pencils or highlighters or something, that might be useful. I'm going to use a highlighter, and I'm going to pick a... Oh, okay, I got yellow selected, and I'm going to highlight my variables here. So I have my 4x and my negative 4x. And those that aren't highlighted, I don't have to collect like terms, or I do have to collect like terms, but I'm not going to highlight them. So the ones that are highlighted, I have 4x minus 4x. Oh, hopefully I got this back now. So 4x minus 4x gives me 0x. And then negative 6 plus 20 gives me plus 14, which is really just equal to 14. And that's my final answer there. Okay, let's move on to the next example. This one, you can do it two different ways, and I'll show how to do that. But first, we're going to do the first step here, which is to rewrite the bracket. Now, here's where things differ. You can do FOIL first, or you can multiply the 2 into one of the sets of brackets. It does get complicated if you do that. The multiplications are a little bit trickier if you do it that way. If you choose not to, that's great. If you choose to, more power to you. I'm not going to, just because I find it easier. So let's get started with this. I'm going to leave the 2 outside of the brackets, and now I'm going to use FOIL. So FOIL is first, so x times x gives me x squared. Outside, which is the first and last, so x times negative 3 gives me negative 3x. Then inner, or inside, negative 3 times x gives me negative 3x again. And then both the last terms, negative 3 times negative 3 gives me positive 9. Okay. I'm going to collect like terms in the brackets first, so I have x squared. Again, you can multiply 2 in at this step. You don't have to. I choose not to until the very end, just because I like to keep all my steps nice and simple. Minus 6x plus 9. Okay. And then now I'm going to multiply in the 2 into each term here. So 2x squared minus 12x plus 18. And I am done with that expression. All right. Let's go to the next slide. Equations. So these were supposed to be revealed. I'll just write it in. Solve isolated variable and check that left side equals right side. So if you're told to check, you have to do your left side, right side check. If it says solve, solve for the variable. So usually that's x. If it says solve and check, you have to solve it and check to make sure your left side equals right side. And to check, you just sub back in your x value or whatever value you found to make sure that your left side is going to equal your right side. If it doesn't, that means that your answer for the variable is not a solution. So you might have to double check your math on that. It's a great tool to use, especially in tests, just because it gives you a bit of a leg up. If you have extra time, you can make sure that you got the right answer. Okay. In example 6, it says solve and check using a calculator. So it wants you to check left side, right side to make sure they're equal. So make sure you do that afterwards. I'm just going to go through solving with you. Okay, so we have a bracket on the left side. We have to expand that bracket first. Same with the right. It does have a negative and then brackets. That means we're going to multiply negative 1 into each term there. So this means that this is going to be 2x minus 6 equals 4 minus 3x minus 2. Because we had to multiply negative 1 into each term. Okay, now we're going to collect like terms. That means I'm probably going to move the x's over to the left side and the constants over to the right. So I'm stuck with 2x, and when negative 3 comes over, I get plus 3x. It's equal to, well, 6 goes over and becomes positive. So I have 4 minus 2 plus 6. So I have 5x equals 4 minus 2 is 2, plus 6 gives me 8. So x in terms will equal 8 over 5. And if you check left side, right side, it should be equal. Next example, we have to multiply our, well, we have to expand the first set of brackets, then we have to find a least common denominator, or least common factor, to eliminate all of the fractions that we have to multiply everything by. And if you don't remember doing this, that's okay. It was a bit of a new technique I taught at the start of the year, and I'll make sure to go through that. Okay, so let's just work through this the way we've been working through it. We multiply into this bracket first. So we have 2 over 3x, and then 2 over 3 times 3 or times negative 3 gives us negative 2, plus 1/2 equals x over 12 minus 1/4. Okay. So now I need to multiply everything by some number that's going to eliminate all of the fractions. And in order to do that, I have to consider all the denominators. The denominators are 3, 2, 12, and 14. What do 3, 2, 12, and 14 all go into? Well, if you said 12, you are correct. We can multiply everything by 12. And if we multiply everything by 12, we're going to eliminate these fractions. So then I'm left, well, 2 over 3 times 12 actually gives me 8x. And then negative 2 times 12 just gives me negative 24. 1/2 times 12 gives me 6. Then I have x over 12 times 12 will just give me x. And then 1/4 times 12, or negative 1/4 times 12 will give me negative 3. Perfect. Now I can collect like terms. I'm going to move the x's over to the left side. And then move the constants over to the right. So I'll have negative 3 plus 24 minus 6. And then I'm left with 7x on the left side. And on the right side, I have 15. So x equals 15 over 7. And that's my final answer for that. Now, this question doesn't say to check. It's just solve, so you don't have to check it. I would recommend checking it anyway, just to practice that using your calculator. Okay, next we have to rearrange the formula to isolate h. And in this case, we actually have to move over the first term. So the first term right here is going to have to move over. So we'll end up with a subtract 2 pi r squared, because it doesn't have an h value in it. And that's just going to equal 2 pi r h. Now we need to divide everything that isn't h in the right side. So if we divide each side by 2 pi r and 2 pi r, what's going to happen is this 2 pi r are all going to cancel out on the right side, and then we'll get h on its own. So a subtract 2 pi r squared all over 2 pi r is going to equal h. And the left side, you actually can't cancel it out because you don't have 2 pi r in a either. That's why you don't cancel it out on the left side, but you can cancel it out on the right because it's in all the terms that are in the numerator. All right, that should be enough for today. I know it was a long lesson. You have an assignment to finish up, so make sure you finish that up. And then you can work on the practice. Try to get that done before next week. I will be doing 2 lessons every week. As far as I know, I might have to change plans, but at the time of recording this, I'm planning on 2 lessons a week and giving you guys another assignment before the end of the year so that you have another chance to improve your mark.